All right, thank you for joining the AWS Cost Optimization Workshop. My name is Lexi Reynolds, and I want to give everyone a welcome to the first event in the series. Today, we will be covering AWS Introduction from Shabir Rupani, Senior Solutions Architect at AWS, followed by an introduction to compute techniques, Spot Instances, and storage with Kevin RisonChu, CTO and co-founder at Stratus10. Before we get started, I want to just go over a few housekeeping rules. If you have any questions throughout the event, please feel free to use the Q&A chat function. We will have time for questions at the end. I'm going to let Shabir now get started.
All right, thank you so much. Good morning, everybody. My name is Shabir Rupani. I'm a senior solutions architect with AWS, and I work in the APN program. It stands for AWS Partner Network, and Stratus10 is one of our advanced partners, and they're part of the APN network. And in this workshop today, we'll talk about cost optimization. But in this particular section, we're going to look at the challenges that many customers face related to controlling their costs and AWS's approach to support their customers, right? And we also will give a brief overview of 5 pillars of cost optimization, and then we'll describe the different strategies. So Kevin will go into depths of the strategies on compute and storage, and we'll just talk about the overview here. All right, so uh, these are some common statements that we typically hear from our customers regarding their cost optimizations. Like, why is my bill so high? I thought I should be saving money. And how can I reduce my cost on dev and QA environments? And what are my options to bring down the cost, right? So all these statements are things that are usually reactive statements, but we hope as you leave this workshop that you will be more proactive by building cost optimization in mind, and we'll identify the areas that you should be looking for and the phases in the project that you should be looking at costs around the costs. So what is AWS's approach? So AWS works relentlessly to reduce our costs. So we have reduced our costs more than 70 times since AWS started. Unlike any other commercial providers, we work hard to reduce our prices. And also we enable customers by providing them tools to look at the cost, analyze the cost, and react to them. So some of the tools that we provide out of the box with AWS are Trusted Advisor, Cost Explorer, right sizing recommendations, and then Spot Advisor, and Cost Optimizer. So these are some tools that come in handy when you want to work on optimizing your cost. And we'll cover a few tools in this series. So may not be in this particular workshop, but the following workshop as well. So we'll cover these tools and talk in details about them. So if you already are an AWS customers, you're already working with a few or all of these roles at AWS. So there is an account manager. The AM stands for account manager. So if you have a large enough usage of AWS, and we also offer what is called private pricing, which your account manager will be able to help you with. And then there's concierge, and this is more geared towards enterprise customers that have access to concierge and TAMs. So those customers are able to leverage recommendations directly from the concierge team. That is a team that works with customers day in day out on these reserved instances and all that. And we also could leverage our partners like Stratus10 in coming up with those recommendations. So you can always work with APN partners on improving your costs and getting your environment cost optimized. And then there you also would have access to an AWS solutions architect to help you or guide you through those recommendations that come out of the box, and also architect the right solution for you. So these are some of the case studies and success stories that we've seen. So like Sprinkler was able to save 2.5 million after optimizing their infrastructure. And then OutSystems was able to save through reserved instance purchases. And Hangama was able to save more than 33% month over month by optimizing their spend. So we hope that the lessons that you learn from this workshop, you will be able to, share your story with others. So with that, let's look at what are the pillars of cost optimization. So there's we've identified 5 pillars of cost optimization: right sizing, um, basically getting the right instance size for your workload. So oftentimes when you start working on on a new workload, you wouldn't be able to do that in-depth testing that you could get only in a production workload. So when you have the right sizing recommendations that come out of the trusted advisor or by any analysis that you do, that is one of the ways for you to optimize your costs. The other way is increase your elasticity. So what it means is, you want to size your environment so it sizes up or down based on the workload or the user number of user requests that come in. So you would want to have your workload elastic enough to react to high load situations, and also scale down when there is not that much activity. And then AWS provides different price models, right? There's on demand pricing, there's reserved pricing, and then also spot instances for EC2 specifically. So you would want to keep this in mind. And Kevin would go into details of this as to what parameters you would look at to pick the right price model for you. But this is something that you definitely have to keep in mind. The next thing that you would want to look at is you want to match your usage to the storage class on the storage. So doesn't matter where the storage is. If it's like object storage in S3, there's different tiers that have different pricing structures and different uses. So you would want to keep that in your mind when you do decide where your data will live. And then there's different types of storage available. There's elastic block storage, and then there's for object storage there is S3, and then there is network storage in forms of EFS and FSX. So these options have different costs and different usages. So you would want to make sure that you pick the most optimum storage for you. And that is something Kevin will again talk about in the presentation. And the last pillar is basically a mechanism to optimize the whole cost overall and work through all these pillars, right? So this would be where you would want to basically create a mechanism of revisiting your costs or looking at your costs and making sure that you're still optimized, all the way through your architecture and at various phases of design. So what I would like to walk you through next is a journey of a customer in cloud in cost optimization. So the way the way you would think about cost optimization is you would think about it from the inception stage. So at each level of your design, you would want to build in that uh, variable for costs into your design, right? So things like serverless or event driven compute, and then again thinking about elasticity with spot instances, with auto scaling groups and triggers around that. Things like that should be kept in mind when you're designing your architecture. So You should not be thinking of cost later. You would want to think about it when you start implementing, because your design could be drastically different when you want to bring in those optimizations into your environment. And again, with implementation, there's different ways to implement, having your non-production environments in a different storage class, and production in a different storage class, retaining the backups, things like that, right? You would want to make sure that you keep that, all those factors in mind. And when the application usage grows, you would also want to keep a watch on the instance sizing and right sizing for your environment in terms of storage, compute, database usage, anything else that you use in your application. Just you have to factor that growth in. So that is why you build a mechanism around costs. And then operational, right? So in your day-to-day usage, you would want to make sure that you factor in optimizations in terms of reserved instances, again, right sizing, using serverless where applicable, and using the right storage types, and building in that elasticity. All right, so with that, I would want to pass this over to Kevin to continue going deep dive into the compute and storage parts of the presentation. Over to you, Kevin.
Thank you, Shabir. All righty. We will dive right on in to compute techniques for doing cost optimization. One of the things this is the quick agenda that we'll go through in this session, looking at operational techniques, architectural improvements, and then spend a little bit of time around the EC2 service itself. So as Shabir mentioned, AWS is constantly looking for ways to reduce costs, in which each generation of the instance family, you're getting better performance and at a lower cost. It's also typically results in you needing to run fewer or smaller instances for your workloads as you migrate onto the newer instances. A few things, though, to keep in mind when you are migrating to the newer instances, though, especially the Nitro-based instances, is that you have to look at the driver update requirements for the instances that you're moving into. Many of the driver requirements may not be there if you're running like a 2008 Windows or an older version of Linux. So you may need to update your OS at the very least in order to take advantage of some of these items. Also, around the virtualization method, HVM is only supported now. PV, which is the older method of virtualization for those previous generations, are no longer in use. So AIMs that still use PV, you'll need to use new AMIs in order to leverage HVM virtualization. The reason why HVM is the default moving forward is because it takes advantage of new virtualization extensions, such as enhanced networking and GPU processing, and gives you better performance because it gives you access to the native hardware platform. So the other thing to check on before you upgrade to a new next generation instance or a new generation instance is make sure you don't have any reserved instances already purchased. Standard RI, best that you wait to do your upgrade until, best you wait to do your upgrade until your reservations expire, because they are set to what you purchased. However, if you buy convertible reservations, then you can migrate and exchange those RIs for the next generation immediately. Okay. And also, when you're migrating, you should consider doing them in small, controllable batches and coordinate either with us or your TAMs to make sure you get the best support during this effort. All right. We mentioned about storage, and we'll dig a little bit more into it, but when you're moving to newer generations of instances, you're going to get EBS optimized instances, and this is offered to you at no charge. The older generations, such as the C1s, C3s, G2s, etc., they do offer EBS optimized, but it's not on by default, and you do have to pay for them. Whereas the newer instances, you get them at no additional charge. So one of the key things to look at around EC2 instances is be sure that you are right sizing your application. And what that means is basically take the bare bones OS, install your application and any necessary components, and then stop. You don't need to install anything else. Then you run your application and determine the right size for them based on that point. So some application upgrades may actually reduce network throughput or CPU memory utilization, which can lead you to reducing your instance size. Okay, it's always important to do continuously reviewing your application versions for upgrades and making sure that any changes that the application does, that you right size your servers appropriately. Around the requirement for licensing, some providers such as Microsoft do require that you use dedicated hosts, which are a per socket or per core license, or they have that requirement. Items like Microsoft Windows, SQL Server, SUSE Linux, even Red Hat can help you meet those compliance requirements. Depending on the dedicated host size, you basically are given a certain number of slots for you to launch your instances. So if say you're launching M5 instances on a dedicated host, you would get 48 slots to launch M5 larges. But if you're trying to launch M5X larges, which are twice the capacity, then that 48 slot drops to 24. So you gotta keep that in mind. But from a licensing perspective, you get dedicated 2 sockets and 48 cores, which allows you to comply with the licensing requirements of those vendors while still running your instances on hosts, and those hosts can share the same license. Okay. Of course, the other option is to look at open source. Look at your licensing options and consider open source alternatives when you're migrating from paid Linux distributions to more open source counterparts like Amazon Linux, CentOS, or Ubuntu. Database licensing can also be a contributing factor. So look to move from paid database solutions like SQL Server and Oracle to more MySQL, Postgres, or even Aurora. Other places where you can save is by purchasing licenses from the AWS Marketplace. Since licensing from Marketplace is on a per hour usage, you can benefit when your software is not in use and you're not under contract to pay for it all the time. You just simply stop your service and you stop paying for that licensing. There are AWS tools such as Application Discovery Service or EC2 Systems Manager, which can help you conduct inventory of your environment and then look for less expensive alternatives than the currently licensed products. All right, so looking at right sizing, there's usually 2 main root causes for why your systems are over provisioned. And we run across this a lot. The first being project prioritization. It's where management or the application owner says, let's just get it up and running and we'll optimize later. And that's fine, but there needs to be a way to monitor that usage and to spend with a planned time to optimize. Otherwise, your TCO, your total cost of ownership for that application, totally gets inflated artificially because you never come back to optimize. Another root cause is not having your telemetry data to know what your historic metrics are. So not knowing how your system is being used and how you're running it especially related to seasonality if you're an e-commerce site, or peak periods for your application. So it's important to identify and address any telemetry coverage gaps that you have, and then measure those metrics such as CPU, memory, disk, networking, to get a better understanding of what your actual usage of the EC2 instance is. And then that'll let you right size appropriately. Very easy to over provision capacity, because we all know that when something goes wrong, you throw hardware at it and you've solved your problem. But down the road, that's going to come back, and probably your CFO is going to say, whoa, 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 why are we spending so much money? I thought moving to the cloud was supposed to save us. And so that's where you have to be sure that you're not over provisioning as much as possible. All right. So if you know the type of workload that you're planning to deploy on EC2, then you may be able to pick the right instance family before you even begin dev and testing. Doing this will save you a lot of time, costs, and reduce the amount of resizing work that you're going to have to do. Okay. Some things to look at when you're looking at the different instance classes are general purpose, which is a more balance of compute, memory, and networking. And it's really designed for diverse workloads or web applications. Where you would be running compute-bound applications or require high-performing processors, you would select the compute optimize. These workloads include media transcoding, scientific modeling, or machine learning. If you've got items that need to work with large data sets in memory, such as database servers, web caches, data analytics, then the memory optimized instances are more appropriate. Accelerated computing for items such as high graphic processing, GPU, where you're GPU bound, ML, HPC, or even autonomous vehicles. And then lastly, storage optimized, which is designed for high sequential read writes, large data sets, NoSQL databases, and Elasticsearch. Okay. There was a feature recently introduced within Cost Explorer called EC2 right sizing recommendations. Once enabled, the recommendation tool provides optimization opportunities for EC2 instances across all your linked accounts, including estimated monthly savings. You can filter the recommendations by regions, tags, linked accounts, and the results are exportable to CSV format. Do note, though, that you will get more accurate recommendations if custom metrics for monitoring are enabled on the instances, and you do that by installing SSM Server Manager agent. Okay, real quickly, want to touch base on the T3 instances, which provide a baseline CPU performance with the ability to burst CPU in any time for as long as required. They're designed for applications that have a moderate CPU usage, but do experience temporary spikes in use and offer a balance of the compute, memory, and networking. Each instance is roughly around 5 gigabytes of networking performance. And then it's one of the cheaper instance classes. Examples for workloads like these may be medium scale databases, virtual desktops, production web servers, even source control repository or dev environments. The T3 family uses a concept called CPU credits, which when the workload is operating below the baseline, then the credits are saved. And then when the baseline is, or the CPU workload exceeds that, then you draw from those credits. All right, and one CPU credit is equivalent to one vCPU running at 100% utilization for 1 minute. So a T3 that has 2 vCPUs, so for every hour the instance runs below the threshold, it can run for 12 minutes at 100% at no extra cost. Generally, if the average CPU utilization is lower than the baseline over a 24-hour period, the hourly price automatically covers all spikes in usage. But if there are situations where your CPU usage spikes for a prolonged period over the amount of credits accrued, T3 Unlimited option will continue to burst, but you are charged 5% or 5 cents for every vCPU dollar hour used. That option, the unlimited, is not checked by default. It is something you will have to manually check when you launch the instance, or you can modify it. Otherwise, if you have it unchecked, then it will only burst until the credits are depleted, and then it will run at the maximum baseline. One thing to save around the EBS cost, storage costs of your EC2 instance, is to look at all your stopped instances. So even if you have an instance stopped, you are still incurring costs for those EBS volumes that are attached. So it's important to be aware of all instances that are stopped, and those that do not have any justification should be reviewed and terminated. You can always take a snapshot of the instance before you terminate it, and now you can put that storage into a much more low-cost storage than what EBS costs. All right. Another one to look at are impaired systems. So an impaired instance is if there's an instance that is not properly started or passed health check of the underlying host. These instances may either be in a stuck state, and you will be charged during this time. So please review your instances that are impaired and terminate them if you can. Alternately, you can stop and start the instance to see if it recovers on the new underlying host. You can also enable EC2 auto recovery, which detects if an instance is impaired and then automatically stop and starts the instances for you. So, we talked about purchasing options earlier. There's 3 main purchasing options when looking at EC2, and these are reserved instances, on-demand, or spot. For instances that are continuously running and have a steady usage pattern, such as like a database, cluster master nodes, baseline loads against application servers, reserved instances are your best choice, since you can predict the usage and you'll get a discount for a term commitment. But for spiky traffic, but predictable usage patterns, such as annual events, like the Super Bowl or new product releases, school registration periods, a mix of all 3 might be appropriate, where you would use your baseline usage running on RIs, and some repeatable tasks like batch workloads that run once a night can leverage Spot or scheduled reserved instances, and then peak periods for these workloads can leverage on-demand or Spot for scaling at a lower cost. If your workload or your usage pattern is unpredictable, or it's a new workload, then it's best to start with on-demand or Spot if your workload is designed to be stateless and flexible. Okay. It's important to avoid paying for instances that are not being used when possible. So if you look at your dev and test, your non-production instances, or instances with scheduled run times, turn them off when they're not needed. Identify when the workload typically runs and any common usage patterns, such as dev instances might only be running Monday through Friday from 9 to 5. Here you can schedule instances to stop after hours. You might have to add batch jobs that run only on weekends. So here you can schedule the instance to start during this time. Or if you have workloads that peak at the end of the month, here you will want to ensure that you have auto-scaling enabled to meet new demand. With auto-scaling, you scale up and down based on demand and usage, which translates to specific metrics such as CPU or number of requests. You can also leverage all 3 pricing options in your auto-scaling group for the most cost-effective strategy. So one way to manage scheduling instances is to use an AWS solution called Instance Scheduler. Okay. Instance Scheduler is a AWS solution that uses a CloudFormation stack that runs in your account and defines schedules that pertain to different workloads, teams, or individuals. The schedules are stored in DynamoDB and can be modified by updating the table or leveraging the included command line tool. You tag your instances with the schedule name, and this solution will automatically start and stop instances within that schedule. This solution leverages CloudWatch events and Lambda to maintain the schedule, at which is also a greater alternative to leveraging for cron-based or schedule tasks that you may run on EC2. Since you only pay for the invocation of the Lambda, which has a free tier of up to 1 million requests per month, it can be significantly cheaper than running an EC2 instance 24/7 to execute the jobs. So regarding Spot, you can save up to 90% over on-demand pricing, but Spot is best suited for stateless or batch processing workloads that can tolerate being terminated. Spot can be used for stateless web tiers and can complement other pricing options such as on-demand and reserve instances to ensure minimum demand is being met. We'll cover the Spot in a future, later, or actually right after this module. Okay, finally, in order to further avoid any unnecessary costs, it's important to ensure that instances are following security best practices, such as only allowing specific ports from the internet and not inviting potential malicious users to rack up your data transfer bills or potentially gain access to your systems. Using a bastion host or even better session manager. So Session Manager allows SSH and DPR or Remote Desktop Protocol, RDP, access to an instance by leveraging AWS's API and IAM for authentication without needing SSH keys. This prevents malicious users from gaining access to your instance by using a shared SSH key. All instances should continuously be reviewed by your team and patched accordingly. And lastly, don't check your access keys into any sort of repository. There are tools out there that can help move your keys into secrets or stored as secrets, which prevents you exposing your keys to the general public. Okay. All right. Let's go ahead and dive right on in to the next segment, which is Spot Instances. Cool. All righty. So with Spot, we're going to cover the benefits of Spot, the rules of Spot, and then handling interruptions and some workload examples. Okay, so companies are using Spots. Basically, these are the big success stories. Lyft is saving up to 90% on monthly using Spot to support their CI/CD pipeline. Yelp is another Spot user that's benefiting from the scaling. Cheaper instances throw more compute processing for their testing requirements and reducing their response times from 2 days to 30 minutes. And Illumina, a local San Diego company here, uses the best of both worlds. Okay. So let's look at on demand. So Spot is one of 3 purchasing prices available to EC2. Among the 3, Spot offers the deepest of the discounts, up to 90%, with no commitment, but The trade-off is that there is a potential for interruption, which we'll cover a little later. But the rule of thumb to evaluate Spot before applying for reserved instances for the best discounts. Okay. So what are some reasons on why you would use Spot? We mentioned earlier that cost plays a significant factor because it's cheaper than your on-demand. Because of this, you're able to launch many more instances for the same price as an on-demand, which will lead to higher throughput and faster results for your workloads. Working with a Spot instance is also very easy and can be launched through a variety of AWS services, such as ECS, the container service, and EMR. Both allow for launching Spots directly from those services. So here are a few simple rules for Spot. So the first is Spot infrastructure or Spot instances are the same instances as on-demand and reserved instances. Spot pricing is set based on long-term trends in supply and demand with an average discount of about 70 to 90% from the on-demand price. If any of you have been using AWS prior to 2017, you probably remember the bidding model that AWS used to run for Spot, but that's been done away with now, and it's resulted in a much more stable pricing and less interruptions for users. The key thing to consider, though, is to make sure that you are diversifying, especially when it comes to your overall Spot capacity. So what that means is having the flexibility to use multiple instance types and availability zones for your workload. So for example, you can use a C4 4x large, but can you use a C5 4x large or a C4 8x large? The reason why it's important to remember that Spot is spare on-demand capacity. So there may be times when there's a spike in demand for a particular instance type and they become unavailable in Spot. If you have flexibility, then it increases the total pool of available Spot capacity for your request and minimizes the impact that you, if AWS has to cause an instance to be taken out of service to meet on-demand requests. Okay, so with that, how are you going to handle those interruptions? Interruptions are important to understand because Spot, by nature, is an interruptible product. So you want to make sure that you put the right type of workload on the Spot. Applications should be able to handle restarting where it left off and not rely on persistent data. Essentially, any application that can be paused, resumed, or restarted can use Spot. Spot usually will give you a 2-minute warning if on-demand users have requested your instance and there's no more additional capacity. This happens less often in instance generations that are not in the latest generation. This is why it's critical to have a diverse selection of instance types and availability zones to meet the needs of your workload. Spot supports several actions that can be taken if it encounters an interruption. Basically, they're terminate, which is where the instance terminates and does nothing, stopping and starting the instance using the same instance type or one of the available instance pools that you have allowed, or pausing and resuming, which is similar to close and open, opening the lid of your laptop. This stores the instance state in memory and resumes where you left off on the new instance. Another feature that was recently released is the capacity optimized allocation strategy. This will ensure that when it spins up a new instance, it picks from a pool that has the most available capacity, further reducing the probability of an interruption. Okay. So now let's walk through a few workload examples that can benefit from Spot. CI/CD, big data, web services, and HPC. Kubernetes runs really well on Spot. So if you have anything running EKS, perfect candidate for running Spot instances. Here it is. Because many workloads running on containers are already stateless and fault tolerant by design, perfect candidate for it. ECS supports it natively, EKS does too. Okay, big data. So with discounts up to 90%, you can scale your compute environment up to 10 times while still staying within your budget. It's integrated directly with EMR or Elastic MapReduce and can support any Hadoop or Spark clusters to process large amounts of data. CI/CD is a growing use case for many customers. Spot provides inexpensive compute environments for developers to build, test, and deploy their code changes. There's also a Jenkins plugin that spins up Spot instances during automated build and testing. Web services is another common use case where you can see a large or a lot of usage in Spot as customers looked for inexpensive solutions to maintain high performance during peak traffic. Very common architecture here is for customers to run baseline using reserved instances for their typical traffic patterns and then scale into Spot instance when traffic gets spiky. And as we'll talk about shortly, EC2 Fleet and autoscaling groups can now support RI on demand and Spot in a single call or autoscaling group, making it much easier to manage. HPC or high performance computing workloads like big data can benefit from the scaling that Spot instances can provide for workloads such as genomic sequencing, computational fluid dynamics, and risk analytics. With Spot, you can run multiple projects simultaneously and reduce the time. A few of our other customers in this space include Illumina, as we mentioned, but also NASA, Autodesk, and Admiral. It does integrate with AWS Batch and CloudFormation and other services. Okay. Now that we've covered the key workloads that you would see in the widest adoption of Spot, let's talk about how to launch Spot instances. So Spot instances can be launched directly in the EC2 console under the Spot instance, but AWS provides tools called Spot Fleet and EC2 Fleet to help manage your Spot workloads without additional management code. With Spot Fleet, you can automatically provision and scale instances across a variety of instance families to meet your needs. In addition, on-demand instances can be mixed in the instance types if you want a number of instances that are not running on Spot and therefore will not have a probability of being interrupted. Spot has native integration with many AWS services, including autoscaling, ECS, EMR, and Batch, as well as third parties like Jenkins, Databricks. And if you'd like to learn more about Spot, we can have an immersion day with some hands-on lab for you. Marquee basically of many of the leading technology companies that are and industry verticals that are utilizing Spot. Okay, and now let's go ahead, jump straight into storage before we move to Q&A. Alrighty. Storage techniques. So we're going to cover real quickly again, operational techniques, architectural improvements. We'll touch a little bit more on EBS storage and then S3. Okay, so EBS or Elastic Block Storage is block storage that's attached directly to your EC2 instances. There's various tiers of storage depending on the level of performance that your workload needs. For instance, if you have a high disk IO intensive application, whether you're doing a lot of writes in a short period of time, the provision IOPS makes a lot of sense for you. But if you're storing data files where latency and IOPS isn't an issue, then you might want to look at lower IOPS options such as cold or throughput optimized, which is much cheaper. Typically, most customers are fine with the general purpose storage since it handles up to 16,000 IOPS. Provisioned IOPS can go all the way up to 64,000 IOPS. So, some techniques related to EBS include deleting unattached EBS volumes. You'll be surprised how many customers have unattached and available EBS volumes still on their account. Many customers may delete tests or old instances and fail to delete the volume, or they'll say they'll save it for later review and then forget about it for years. So you want to select the right storage type for your workload. There's no need to have a provisioned IOPS if you have data that's not going to be frequently accessed. Monitor your IOPS usage using CloudWatch to determine the best fit for your storage needs. Provision only the storage that you need and use elastic volumes. You no longer have to over provision your storage since it can scale to the volumes you need as you need them. Some instance types do include ephemeral storage, so leverage those as it's no additional cost, but keep in mind, data on ephemeral storage is lost once the instance is stopped or terminated. So only look to store temporary credentials or temporary data like cache files. Okay, EBS volumes that already have provisioned IOPS, and you'll notice that you aren't using more than 16,000, you can simply switch to GP2, which is much lower cost. Also look at GP2 storage to see if you have infrequent workloads and migrate those to lower tier storage as well. Lower tier storage is optimized for large streaming or big data workloads where throughput is a better performance indicator than IOPS. Okay. Quick note on the elasticity of EBS. Once you provision an EBS volume, you can't implement any of the best practices related to changing your size and type without any downtime. This makes it much easier to reduce costs when impacting your workloads. Note that volume sizes cannot be reduced using this method, only grown. And while it's understood that some customers have retention policies that require them to store snapshots over the backups for a period of time, it is important to check with your security policy, such as retention policies and snapshot frequencies, and purge snapshots that you no longer need. You can use tagging on the snapshots to help identify the purpose of the snapshot, as well as identify an expiration date of when it's safe to delete. EBS Lifecycle Manager, which was introduced in June of 2018, is a great way to automatically handle the EBS snapshot management of your volumes. You can apply the same lifecycle policy, the volumes with particular tags. So example, you may have a different policy to backup development volumes than you would production. You define your schedule and a retention rule to automatically purge snapshots that you no longer need. And you can then automatically tag your snapshots using the volume tag for your own. EBS-backed AMIs are made up of snapshots of EBS volumes that form the AMI, which you will have to pay for storage fees. So be sure to review your AMIs and delete the obsolete ones. Be careful not to delete old AMIs that some older running instances are using in case you do need to rebuild that instance or scaled to an auto-scaling group that AMI is in a launch configuration for. Okay, let's talk about S3 cost optimization now. So like EBS, S3 offers different tiers based on how frequently you use the data. For hot or frequently accessed workloads, S3 standard should be your default option. Warm or infrequent access to data, there's a S3 infrequent access. And if your workload allows less availability, S3 one zone is available for even greater reduced costs. For cold or rarely accessed storage, you can use Glacier, which stores objects at a significantly cheaper rate and gives you the options of expedited retrieval for a fee if you need to get to that data quickly. Glacier Deep Archive is an option for the cheapest storage costs, but keep in mind that retrieval times do take around 12 hours for standard or 48 hours for bulk retrieval. So it's common that more recently created data is the more frequently accessed data. As data ages, data becomes less frequently accessed. So a proper lifecycle policy should be put in place to identify what type of data this is, how it should be tagged, and what are the rules on which data should be deleted. Like EBS, you should choose the best storage class that matches your workloads. Place more frequently accessed data in S3 standard and less frequent in the lower storage class. Enable lifecycle policies to move your data to lower storage classes based on their age, and then purge incomplete multi-part uploads. Review versioning to see if it is needed, and configure the lifecycle policy to remove older versions that are no longer required. You can enable automatic intelligent tiering, which continuously reviews your objects in S3 and then places those objects in the appropriate storage class. Do note, however, that intelligence tiering currently supports objects above 128K. For objects below 128K, or if you want to manually review your S3 access patterns, you can use S3 Storage Analytics. S3 Storage Analytics allows you to review any spikes or anomalous usage, and also determines the appropriate lifecycle for your data that is in S3. Up to 10 per million objects monitored each month. 10 cents for every million objects monitored each month. Other considerations regarding S3 are to keep an eye on your S3 buckets that have suddenly spiked in usage, which can include unintended verbose logging or applications that missed a cleanup step. Also try optimizing your API calls to S3 by batching operations where possible to reduce API costs. All right, with that, we are at the end of our presentation. Are there any questions at this time? Let me see, I have to pull up the Q&A window, unless Lexi has that available.
I do not see any questions now.
Okay.
All right, well, I do want to thank everyone for joining today. We will be sending an email with a recording of the live webinar, as well as the slides for you guys to review. And if you have any questions, feel free to reach out to me on that email, as well as if you want more information on the Stratus10 cost reduction program, I'll be sending more information in our follow-up. That's a program that we're running to help you reduce cost by up to 30% in the first 3 months. Thank you guys for joining the first in the AWS Cost Optimization webinar. We will be running other events this month, and I'll give you more details on that as well in our follow-up email. I encourage you to sign up for any that you can make, and feel free to invite all your colleagues. If you guys don't have any questions, I'm going to end the event.
Lexi, looks like someone has a question.
Oh.
Can you talk about duration for S3 30 days for warm? Let me take a look. I'm not sure what. If the assumption is any data that's accessed in 30 days is considered warm data, it's really more of your own company policy. Some companies may consider data within the quarter to still be warm, but some may say, after a week, we're not going to be accessing that data again. So you would have to set your data lifecycle policies based on your own company determination. I hope that answers your question. All right. If there are any future questions, you can please go ahead and reply to the I think you reply to the invite. If not, send it to info@stratus10.com, and we will be happy to answer them for you. Okay. Thank you very
All right,
much.
thank you guys for attending the first event in the Cost Optimization live webinar series.